Welcome back everyone. In the previous tutorial, we learned how to calculate the confidence intervals for two dependent samples. And now we are going to learn how to calculate the confidence intervals for two independent samples. And when we say two independent samples, we mean these two samples are completely individual. They are not related to each other. And in this scenario, we want to conduct a study on a group of students in two different schools, in school A and school B. We want to find if there is any difference in the average grades for the students in school A and the students in school B. So we are assuming that these two groups are completely individual. And that makes sense. We cannot find any student go to two schools at the same time. And when we have two independent samples, we will have three scenarios. First scenario, we have known population variances. And the second scenario, unknown population variances, but assumed to be equal. And the third scenario, unknown population variances but assumed to be different. And this is a rare case that we use in the actual life. So our focus will be on the first and the second scenario. We will start first when the population variances are known. So we draw 60 observations from the school A and 40 observations from school B. And we found the sample mean for the grades in school A is 85%. And the sample mean for the grades in school B is 91%. We can say, based on a previous study, population standard deviation of the grades in school A equal 7%. And the population standard deviation of the grades in school B equal 13%. So our assumptions here, we have known population variances, which are 7% and 13%. Populations are normally distributed, and we got two different sample sizes. And the last assumption here, the two samples are completely independent. So we need to find the difference in grades between the students in school A and school B, with a confidence interval 95%. So in the next tutorial, we are going to calculate the confidence interval.